Good afternoon, everybody. Yes, so we're a demonstration of our VXLAN gateway. And when we do VXLAN gateway, we're trying to kind of do a couple of things. We want to do scaling. So the whole idea is to be able to scale EVPN domains. So I'll talk a little bit about how we introduce hierarchy. And we're also going to do things like with the gateway, we're also going to do things DPath for loop protection and UMR as well, which is going to help with the scaling. So what do we mean and what we plan to do here? As I say, so this gateway, in this particular demo, we're going from an EVPN domain to another EVPN domain, but we're keeping the transport the same. So we're going from EVPN VXLAN to another EVPN VXLAN domain. Why are we doing this? Again, it's all about scaling, hierarchy, but at the same time, we're still allowing you to do layer 2, full layer 2 stretch between the two domains, and full layer 3 VPNs as well between the domains. And as I say, you'll see what the gateway is actually doing to allow that to do that functionality, those VPNs at the same time for scaling. So typical use cases, as I say, is this would be DCI, so data center interconnect. Other use cases is when you're building a large data center. You're looking to build each row, your data center could be its own EVPN domain. So you want to interconnect all those different rows, still have layer 2, have layer 3 connections between the rows or the different floors of the data center. So you can have different pods and you have a gateway per pod to interconnect them seamlessly. Right? So what we're going to do here is all standards based, as you would expect. So a couple of different drafts and RFCs. So for the layer 2 piece, this is RFC 9014. So that's with the layer 3 piece when we do layer 2 or type 5 routes between the gateway. And then when we do the type 2, it's another draft, sorry, type 5s, it's an IPVN to EVPN draft. So couple of things, as I say, just to give you an idea in the diagram here, is this is kind of the first piece of the solution, is that you're going to introduce hierarchy when you re-advertise the routes, right? So here I'm showing you the behavior from left to right. So the PE1 is advertising a set of type 5 routes, so IP prefixes, and it's also advertising MAC addresses, right? So type 2 routes. So it's advertising them within its domain, and then provide connectivity across domains. The gateway is going to take those routes, but when it re-advertises them, it's going to change the next hop. Right? So therefore, that allows the next hop to be changed, and therefore any remote device only has to have connectivity to the gateway itself, rather than any PE within the domain. Right? The other piece that's happening here as well, if you note at the bottom of the diagram, is when we stretch layer 2, we're going to improve the scaling by the fact that we're going to create multiple flood domains. So any traffic that wants to flood within the domain on the left-hand side only has to flood its local PEs and the gateway. The gateway then floods the traffic to the remote gateways, right? So you end up creating multiple flood domains. The other function of it is going to do as well is actually going to scope certain routes. So you don't re-advertise every route in every domain into the neighboring domain. So we don't only re-advertise type 2s and type 5 routes. Any type 1 routes, type 3 routes, type 4 routes don't get advertised outside the domain, right? So again, these are all the things that you're going to do. Scaling better, less routes between domains, less states between domains. The other part is the DPath. So DPath, as we advertise routes between the domains, we're going to add a DPath to tell where the route came from, so that the peer, if you're doing any sort of redundancy, your peer gateway that's connected to the same domain can make the decision of where it's going to re-advertise the route. Right, so it looks at the DPath, and we'll see this in the demo. Based on the DPath, it can decide where the route came from, and therefore where it's going to advertise it to, and where it's not going to advertise it to. So in this case, Gateway 2 is receiving, or Gateway 1 receiving routes from Gateway 1 is receiving routes from Gateway 2, and because of the DPath, it doesn't advertise it back into the domain, right? So preventing route protection. And then the third part of the demo is going to be what we call UMR, or unknown MAC route. So again, the whole idea here is all about scaling. So instead of learning all the MAC addresses in the remote domain, and then re-advertising them all into the local domain, and therefore all your PEs learn all those MAC addresses, even though they have the same shared next hop, which is the gateway, what we can now do is aggregate all those MAC addresses that learn in the remote domain, and the gateway will just advertise a single route to represent all those MACs in that bridge domain. And that route is called the unknown MAC, or unknown MAC route, right, or UMR route, right? So again, we'll show you this in the demo. So this is the topology of what we have set up. So we have just similar, we have a couple of domains. So on the right-hand side, we have a PE, and in there you have you basically get a layer 2 stretch between the 3 domains. and you have layer 3 connectivity between the 3 domains as well, right? So you've got domain on the right-hand side, and I've given it a domain ID of 333, and this is what's going to be added to any route learnt in there when the gateway re-advertises it. I have an interconnect domain, which is 222. So anything that comes in or learnt 222, when it re-advertises into the left-hand side domain, is going to have that D path added to it. 333, 222, and then re-advertised. So what I'm going to show you here is MAC routes being advertised across the domains. So as they get advertised, we can see the D path being added. And then what we'll then do is add the UMR route, so that when the gateway learns the MAC routes on the remote end, we'll then aggregate all those MAC routes and just advertise a single UMR route into the domain 111. All right, so we'll see the UMR route, and we'll also see the D path being added to the route as well. So this is me on the PE on the remote hand side, if you remember the diagram. So this is in the remote domain, and you can see if I look at the MAC address on this box, I'm going to look at what the VLAN in this case has been stretched is 1301, and you can see that I'm learning 2 MAC addresses. I have learned this MAC locally on the box, okay, and I've learned this second MAC via EVPN. All right, so I'm going to look at the local MAC and see how in the control plane how it's advertised across the domains. So see it being advertised. You can see it being advertised with this node's RD, and it's going to be always advertised with this node's next hop. If I then go on to the gateway itself, so this is the gateway I'm now on, and I take the same route, you can see I'm learning that route from the node 18, so the PE, with the next hop of 18 as well, right? I can put the detail in. So you can see I'm learning from this node here, okay? When I then go to the spine, sorry there, I think I picked the wrong MAC as I was going on. So I can see here that the gateway is learning this MAC, and it's learning it with the 18, sorry, as the next hop, right? So what we're now going to show now is the route being advertised by the gateway onto the spine. So you can see now 2 things: with the routes being advertised by the gateway onto the spine, a couple of things you can look at the route now. You can see the next hop's changed to 14, which is the gateway. And probably more importantly, is you can also see that it's added a D path to the route. So this is a D path to make sure to say where the route came from, and therefore to make sure the route isn't re-advertised back into the domain it was learnt on, right? So this is the D path that's been added by the gateway for that route detection. The other thing to note what's happening at the moment as well is you can see that I'm advertising all the MACs that I learned in the remote domain, but I'm also advertising this unique MAC. This is a UMR route, right? So default behavior, I'm going to advertise the UMR route. I'm also going to advertise the MACs themselves. Why do I do that? I do that because the PEs are sitting in this domain. I don't know if they can install that UMR route. Right, so to make sure for any legacy device that can't install the UMR route, I'm going to advertise the UMR. They'll install that. If I can't install the UMR, then the other devices will use the MAC route itself, right? Now, if I had a setup whereby all the devices in the domain did install the UMR route, then what I can then do is just stop advertising it any other routes, right? So that's what I'm going to do now on the gateway. So this is going to say, advertise the UMR route, but don't advertise any other MAC route. So if you look, again, just double check here, you can see these routes being advertised by 14. And now I'm going to disable, now I go back onto the spine. What am I advertising into this domain? I'm now only advertising the one route. All right, so I've decided that everybody in my domain can install and understand the UMR route. Therefore, I then aggregate all the routes and just advertise one route. All right, so again, this is all about how you can improve scaling. One final thing, on the gateway itself, we talked about stretching layer 2, right? So on the gateway itself, you can see now, I've actually got 2 different flood domains for forwarding broadcast traffic on the gateway, right? So it's going to learn the PEs in its local domain. So this is, in this case, 11 and 12. So if I get any broadcast traffic from the remote domain, I'll flood it to 11 and 12. but I also have a separate flood domain for traffic going from the local domain to the remote domain. In this case, it's a remote PE. So that means any traffic in the local domain, the gateway receives it, he only floods it to 18. All right? So again, this means you're improving your scaling with your flood domain as well. So that's me. I'll be hanging about here for the next 10-15 minutes if you have any questions.
Yeah, thank you very much, Alex.
Back to you, Carsten.
Much appreciated. So you see, EVPN over VXLAN is a very mature technology, and we are really testing the interoperability of advanced operational optimizations here. The test report is only the very short version. We have a much, much bigger version online available with all of the detailed test results also from the test case that Alex presented now. Thank you very much.